Spherical Geometry, Understanding Our Earth, an exploration of how we map and navigate our spherical world using mathematical concepts. Lesson Overview: Earth as a sphere. Understanding the shape and dimensions of our planet. Latitude and longitude, the coordinate system that helps us locate any point on Earth. Great and small circles, different types of circles on a sphere, and their properties. Practical applications, how these concepts help us navigate and understand our world. The Earth. Not quite a perfect sphere. The Earth is approximately spherical in shape with North Pole at the extreme upper part, South Pole at the extreme lower part. Flattened poles, not perfectly circular, an axis running through the center from North to South Pole. Earth's dimensions: 6,360 to 6,380 kilometers. Varying radius. The radius of Earth is not constant, reducing from the equator towards the poles. 6,400 kilometers. Approximate radius. For calculation purposes, we often use this simplified value. 40,075 kilometers. Equatorial circumference. The distance around Earth at its widest point. Like Earth, an orange is another example of a sphere with slight variations in its perfect roundness. Imaginary lines, our mapping system. To locate positions on Earth's surface, we use a system of imaginary lines called latitude and longitude. These lines form a grid that allows us to pinpoint any location with precision. Great circles. A great circle is formed when a plane passes through the center of a sphere, creating the largest possible circle on the sphere's surface. On Earth, great circles include the equator, horizontal great circle, all lines of longitude, meridians. Great circles always have the same radius as the sphere itself. Small circles. A small circle is formed when a plane intersects a sphere without passing through its center. On Earth, small circles include all lines of latitude except the equator. These are also called parallels of latitude because they run parallel to each other. Small circles always have a radius smaller than the sphere itself. Latitude, measuring north-south position. Equator, 0 degrees. Measured as angles from 0 degrees at the equator to 90 degrees at the poles. Degrees north and south. The reference line for measuring latitude, dividing Earth into northern and southern hemispheres. Parallel lines. Lines of latitude run east-west, parallel to the equator and to each other. Understanding latitude angles. The latitude of a point is determined by the angle it makes with the center of Earth and the equator. North latitude. If point A is north of the equator and creates an angle of x degrees at the Earth's center, then the latitude of point A is x degrees north. South latitude. If point C is south of the equator and creates an angle of beta degrees at the Earth's center, then the latitude of point C is beta degrees south. Longitude, measuring east-west position. Prime meridian, 0 degrees. Measured as angles from 0 degrees at the prime meridian to 180 degrees east or west, degrees east to west. The reference line for measuring longitude, running through Greenwich, London. Meridians. Lines of longitude run north to south from pole to pole, converging at the poles. The prime meridian. The prime meridian is designated as longitude 0 degrees and serves as our reference point. Passes through Greenwich, London and Tema, Ghana. Sometimes called the Greenwich meridian. Longitudes to the left are west. Longitudes to the right are east. Understanding longitude angles. The longitude of a point is determined by the angle it makes with the center of Earth and the prime meridian. West longitude. If point P lies west of the prime meridian and subtends an angle of theta degrees at the Earth's center, then the longitude of point P is theta degrees west. East longitude. If point R lies east of the prime meridian and subtends an angle of theta degrees at the Earth's center, then the longitude of point R is theta degrees east. Coordinate system, putting it all together. Ordered pairs. Geographical locations on Earth are expressed as ordered pairs in the form latitude, longitude. Example: Lagos, Nigeria, is located at 6 degrees north, 3 degrees east. This is written as 6 degrees north, 3 degrees east. Direction indicators. N means north of the equator. S means south of the equator. E means east of the prime meridian. W means west of the prime meridian. Shorthand notation. Sometimes locations are written in a shortened form using a letter to represent the city. Example: Kumasi, Ghana is at 6 degrees north, 1 degree west. This can be written in shorthand as K, 6 degrees north, 1 degree west. Example: locating cities. Kinshasa, 16 degrees south, 25 degrees east. To locate Kinshasa, first, find 16 degrees south of the equator. Then, find 25 degrees east of the prime meridian. The point where these two lines intersect marks Kinshasa. Libya, 35 degrees north, 42 degrees west. To locate Libya, first, find 35 degrees north of the equator. Then, find 42 degrees west of the prime meridian. The point where these two lines intersect marks Libya. Radius and length of latitude. As you move from the equator toward either pole, the circles of latitude become smaller because their radius decreases. Equator, the largest circle with the greatest radius and circumference. Mid-latitudes, medium-sized circles with smaller radius than the equator. High latitudes, much smaller circles close to the poles. Poles, the latitude circle reduces to a single point. Opposite points on Earth. If 2 points lie on opposite ends of a diameter through the Earth's center, they are called antipodal points. For longitude, you subtract the given longitude from 180 degrees, and switch from east to west or from west to east. Example: if point X is at longitude 19 degrees east, the opposite point Y is at longitude 161 degrees west. For latitude, you keep the same degree but change north to south or south to north. Example: if point X is at latitude 52 degrees north, the opposite point Y is at latitude 52 degrees south. Practical application: school campuses. Diligence campus is located at 60 degrees north, 55 degrees west. Peace campus is located at 60 degrees north, 20 degrees east. Wisdom campus is located at 35 degrees south, 55 degrees west. Alakuko campus is located at 35 degrees south, 20 degrees east. Historical measurement. In the 18th century, the length of 1/4 of Earth's circumference was taken to be 10,000 kilometers. The circumference of a full circle is 2 times pi times the radius. Therefore, 1/4 of the circumference equals 1/2 times pi times the radius. So, 10,000 kilometers equals 1/2 times pi times the radius. Solving for the radius gives radius equals 10,000 divided by 1/2 pi. That equals 10,000 times 2 divided by pi, which is about 6,369 kilometers. This is remarkably close to our modern measurement of 6,371 kilometers. Key concepts review. Earth as a sphere. The Earth is not a perfect sphere but very close to spherical, with an average radius of about 6,400 kilometers. Equator and prime meridian. The equator is the main reference line for latitude at 0 degrees, dividing Earth into northern and southern hemispheres. The prime meridian is the main reference line for longitude at 0 degrees, dividing Earth into eastern and western hemispheres. Coordinate system. Any place on Earth can be described using an ordered pair of numbers: latitude, longitude. This tells us how far north/south of the equator, and how far east/west of the prime meridian the place is located. Great and small circles. Great circles are the largest possible circles on Earth's surface, made by slicing Earth through its center, e.g., equator or meridians. They represent the shortest distance between 2 points. Small circles are any other circles that don't pass through Earth's center, e.g., lines of latitude other than the equator.